Hey there, CJ Math students. So today we're going to use the commutative and possibly associative properties to solve some problems with rational numbers. The whole idea about today is sometimes math problems look super complicated, but if we rewrite them, reorder them in the way that we want them, we can see things that make them a lot easier. So let's go ahead and start with exercise 1. It says unscramble the cards and show the steps in the correct order to arrive at the solution to 5 2/9 minus 8.1 plus 5 2/9. So let's go ahead and write out the problem here. We got 5 2/9 minus 8.1 plus 5 2/9. So first off, you need to understand that this minus sign out here gets distributed or multiplied into both terms on the inside. So this goes to the 8.1 and this goes to the 5 2/9. So we have 5 2/9 minus 8.1, because I'm minus sign times an 8.1, or a negative times an 8.1, and minus, sorry, plus minus 5 2/9. All right. In doing that, we hopefully can see something right off the bat. First of all, we want to go ahead and say plus a negative there. We leave that alone because it's got a plus sign. And let's use the commutative property of addition to say, hey, let's break apart 5 2/9, or let's put 5 2/9 next to 5 2/9. So let's use that. 5 2/9 plus negative 5 2/9 plus negative 8.1. And in doing so, hopefully you realize that 5 2/9 plus negative 5 2/9 are opposites, and opposites add up to 0. And so those will cancel out. I'll have 0 plus negative 8.1, which gives me just negative 8.1. So a problem that looked super complicated to start off the bat ended up being very easy. Let's take a look at number 1. So again, you might be tempted to go ahead and change this to plus negative. Go ahead and do that. Plus a negative, but now realize that this negative sign goes to both terms on the inside. So this becomes 4 4/7 plus negative times 4 4/7 is negative 4 4/7, and make sure you put that negative sign there, right? Plus, and then a negative times a negative, we're going to learn, is actually a positive. So a negative plus a negative is still a negative, but a negative times a negative is a positive. So go ahead and write that down. Negative times negative equals positive. Very different from a negative plus a negative, right? The negative plus a negative, negative plus a negative still equals a negative. Makes sense, right? If I move along the number line and I say negative 5 and then say plus negative 3, I'm just moving left. The negative times a negative will equal a positive. So we're going to have a negative sign times a negative sign gives us plus 10. So now hopefully we're recognizing right off the bat, hey, I've got 4 4/7 plus negative 4 4/7. Those are opposites, and because they're opposites, they cancel out. They're equal to 0, so we can just put slash marks through there. So you can say 0 plus 10. 0 plus 10 should just give you your answer of 10. So your answer here is 10. Let's do number 2. Number 2 should look familiar. It's one of those problems where we need to borrow. So let's go ahead and say 5 plus negative 4 plus, remember, we're going to break that up into negative 4 and negative 4/7. Remember, both parts of the fraction are negative, the whole number and the fraction. So now we'll go ahead and say 5 plus negative 4 gives me positive 1, right? Because this is a DSSL. And plus negative 4/7. Now, I would love just to put these together and say my answer is 1 4/7, but I can't, because this guy right here is negative. Super important to remember your negative signs. So what do I have to do to 1? I have to rewrite 1 so I can work it with negative 4/7. And so I write that as 7/7, because what's 7/7? It's still 1. So 7/7 plus negative 4/7. I have not changed the problem. But now I can rewrite this, and I can work this as a DSSL. So 7 plus negative 4 is really 7 minus negative 4, which gives me 3. And keep the denominator of 7. And my answer is positive because I had more positives than I did negatives. So 3/7 is my answer. All right, number 3, we're going to have to do some plus negative stuff here first. So negative 5.2 plus positive and then we keep that. All right, so we write out the problem, negative 5.2 plus 3.1 plus 5.2. Hopefully you're starting, if you scan this, to see something right off the bat that you say, aha, let's use commutative property to rewrite this. And hopefully you realize, hey, I got 5.2 and 5.2. So negative 5.2, important to keep your negative sign, plus, use the commutative property to switch these two terms, 5.2 plus 3.1. Notice when you use the commutative property, you don't lose any of the terms. You just reorder them so that you can see stuff a little bit better. So these two right here are opposites. So because they are opposites, they cancel out and they equal 0. So 0 plus 3.1, and then 0 plus 3.1 should just equal 3.1. Right, number 4 is very similar to number 2. So let's do number 4. 32 plus, break this apart, negative 12 plus negative 7/8. It's very important that you realize that both parts of this fraction are negative, the whole number and the fraction. So negative 12 and negative 7/8. And so 32 plus negative 12, that's a DSSL problem right there. We're basically going to do 32 minus 12. We have more positive numbers, so 32 minus 12 will give us a positive 20 plus negative, keep your negative sign, 7/8. Got to be a surgeon when you do this stuff, guys. The smallest detail matters. All right, so now we have to borrow one whole from the 20 because these are opposite signs, and I have to borrow a whole to get 8 over 8 to be able to subtract this. So this becomes 19, right? And then the one whole is 8 over 8, determined by this denominator right here, plus negative 7/8. And now that I have this part right here, I can go ahead and subtract. So 8 plus negative 7, again, DSSL, I have more positives than I do negatives. That will give me positive 1/8. So I have 19 plus positive 1/8. And because those are the same signs, I get to slap them together now, and I get my mixed number of 19 and 1/8. That's my answer there. Go ahead and pause this video and go on to part 2.